Good morning students, welcome to Crashing Online Classes. In the previous class, I have started the lesson Force and Pressure and I also discussed the effect of forces. So which are the effects of forces, using force, which activities we can do as we have studied. By applying the force, we can make a stationary body to move. If a body is in the stationary position, to make it to move, we have to apply the force. In the same way, by applying force, we can make a moving body stationary. A body which is moving, to bring it to the stationary position, we have to apply the force. By applying force, we can change the speed of the body. We can increase the speed or we can decrease the speed of the body. And also, by applying force, we can change the direction of the motion of the body. To change the direction of the motion, we have to apply the force. And also, force is required to change the shape of the body. These all we call it as effects of forces. In the sense, what changes takes place by applying force, the changes which takes place, we call it as effects of forces. So in this session, we will study about types of forces. Forces are mainly classified into two types. They are contact forces and non-contact forces. Contact force and non-contact force. First we study about this contact forces. As the name indicates, what do you mean by contact force? If there is contact between two objects, the force exists. We call it as contact force. The force exists between two surfaces of the object which are in contact with each other. If two objects or two bodies are in contact with each other, the force exists. We call it as contact force. There are two types of contact forces. They are muscular force and frictional force. So what is this muscular force? As the name indicates, the force which we apply by using our muscles. It is called a muscular force. In the sense, to perform any activity, we have to apply our force. We have to apply the force using our muscles. For example, pulling a door or pushing a door. When you want to close the door, you have to pull the door. By pulling the door, you are applying force on the door using your hand. For example, if you want to push a table, what happens? By using your hand, you are applying force on the table and you are pushing the table. So here force applied is muscular force. In another way, when I am writing on the blackboard, so what happens here? I am applying my force on this chalk piece and I am writing on the board. So the force applied is muscular force. When I want to erase the board, rub the board, what happens? I have to take the duster and I have to apply my force. In the sense, the force using my muscles and I have to erase the board or rub the board. So in all these cases, what happens? The force is applied due to the contact between two objects. For example, if you take erasing or rubbing the board, there is contact between the board, duster and my hand. So I am applying force on this duster and I am rubbing the board. So there is contact between the two objects. Such a type of force is called contact force. One example for this contact force is muscular force. Second one is frictional force. This is also one of the contact force. So what is this friction? What do you mean by frictional force? Where you can see this friction. For example, consider you are pedaling a bicycle. So suddenly you apply the brakes. When you apply the brakes, what happens? Bicycle travels a certain distance and its speed decreases and at the end it comes to the rest position. When you are applying brake on any vehicle, it may be car, bus or anything, what happens? After moving a certain distance, speed of the bus or the car or any vehicle, it goes on decreases and after reaching a certain distance, it travels a certain distance and it stops there. Consider rolling a ball on the ground. So what happens when a ball rolls on the ground? It travels a certain distance and suddenly it comes to rest. A ball, for example, consider a ball which rolls on the ground. It travels a certain distance and ball, surface of the ball and on this floor, the ground, the surface between the ground and the ball, the force present, the force acts, that is the frictional force. And remember, if the ball moving in this direction, frictional force acts in the opposite direction. The force of friction is always opposite to the movement of the object. It is opposite to the motion of the body. When you pedal the bicycle, when you stop pedaling the bicycle, or when you suddenly apply the brake, what happens? Bicycle moves a certain distance. Because of the friction between the tire and the road, bicycle comes to the rest position. So in this case also, if the bicycle is moving in the forward direction, frictional force acts in the backward direction. So always remember, the force of friction acts opposite to the movement of the body, the direction of motion of the body. It is opposite to the direction of motion of the body. So frictional force exists if there is contact between two objects. If the contact between the surfaces of two objects, that is a frictional force. Therefore, muscular force and frictional force are examples for contact force. So contact force, it is a force, the force which exists if the two bodies are in contact with each other, or the surfaces of two bodies are in contact with each other, then the force exists is contact force. Example, muscular force and frictional force. Now come to the second type of force, that is non-contact force. As the name indicates, non-contact. So the force which exists when two bodies are not in contact with each other. If the surfaces of two objects are not in contact, they are not in contact with each other, the force exists is called non-contact force. We can give here three examples. The examples for non-contact forces, they are gravitational force, magnetic force and electrostatic force. First one is gravitational force. So what is this gravitational force? You all know that if we throw any object, if I throw this chalk piece travels a certain distance and once again it falls back to the earth. Or if we throw any object from the surface of the earth, once again it falls back to the earth. So why this happens and what is responsible for this? This is because the gravitational force. Earth has gravity, in the sense earth has the capacity to attract each and every object towards its center. Earth has the gravitational pull. Earth has the gravitational attraction. Earth has the gravity. Because of this gravity, gravity is nothing but force of attraction. Because of this, all the object falls back to the earth. If you throw any object on the surface of the earth, once again it comes back to the earth. It falls to the earth. Because earth has gravitational field or earth has gravitational force. Earth has the gravity or the force of attraction. So this is called gravitational force. So this gravitational force exists if there is no contact, if two objects need not be in contact with each other. For example, earth and this chalk piece. There is no contact between this chalk piece and the earth. Still, if I throw this chalk piece, it falls back to the earth. So the force exists, that is non-contact force. Come to the second example, magnetic force. It is also non-contact force. So what is this magnetic force? So you know that magnet has the force of attraction. If you bring the magnet towards an iron nail or any magnetic materials, they get attracted. You can see the attraction between the magnet and the magnetic material. This is called magnetic force, the force exerted by the magnet towards the magnetic material, or you bring two magnets in contact with each other, you can see this magnetic force. But you have to remember, as you have studied in your previous classes, magnet has two poles, north pole and south pole. So where you can see the attraction, if you bring north pole and if you bring south pole, if they repel each other. They repel each other. They get repelled. Like poles get repelled. But if you bring North Pole and South Pole or South Pole and North Pole near to each other, if you bring them near to each other, they get attracted. They get attracted. So, like poles repel. Like means north, south, south. Like poles repel each other. But unlike poles, South Pole and North Pole or North Pole and South Pole, they get attracted each other. This is also non-contact force. Come to the third one, that is electrostatic force. So, electrostatic force means the force exerted by a charged body. Force exerted by a charged body on another charged or uncharged body. On another charged or uncharged body. The force exerted by a charged body on another charged or uncharged body is called as electrostatic force. Here also, like charges repel each other and unlike charges attract each other. So, gravitational force, magnetic force and electrostatic force. These are non-contact force because the force exists if there is no contact between the two objects. If two objects or two bodies are not in contact with each other, but still we can see the force, that is called a non-contact force. Now we will see these forces by performing some activities. Now we will see the examples for non-contact forces. So as I give an example, magnetic force is a non-contact force. It attracts some of the magnetic materials like a piece of iron or the steel. There is no contact between the two objects, but still magnet attracts the magnetic materials. So this is an example for non-contact force. And also I said the like poles of the magnet repelled each other and the unlike pole gets attracted each other. So these two are the south pole of the magnets. When you bring south to south poles towards each other, when you bring south to south pole, they get repelled. You can see here carefully, just observe carefully. When you bring south to south pole near each other, they get repelled. When you bring north to north pole towards each other, they get repelled. They are not attracted, they get repelled. But when you bring south pole and the north pole towards each other, when you bring a south pole and north pole, they get attracted. So this shows that like poles repel each other, but unlike poles attract each other. Like poles, you can see the repulsion. So clearly you can see here the repulsion between the like poles. Now we'll see one more example for non-contact force. So one more example I have given, electrostatic force. So what is electrostatic force? The force exerted by a charged body on one more uncharged body or the charged body is called electrostatic force. To see this, take a piece of straw and tie it to a thread. Connect the thread or tie the thread to a stand. Now just hang this straw like this. Now take one more piece of straw. Bring this straw near the first straw. Can you see any attraction here? You cannot see any attraction. Now take a piece of paper and rub this straw with a piece of paper. In the sense, I am charging the straw. The straw gets charged if you rub with a piece of paper. Charge it nicely, charge the straw. Now bring this charged straw near an uncharged straw. Can you see the attraction here? Can you see the movement? So this is called electrostatic force of attraction. So here this straw is charged, this is uncharged. The charged body attracts an uncharged body. This is called electrostatic force of attraction. Now you just charge the second straw also. Charge the second straw. By rubbing with the piece of paper. And bring the first straw near second straw. Can you see the attraction here? The second straw is moving away from the first straw. So what you can see here, it is a repulsion. So already I told, charged body like charges repel each other, unlike charges attract each other. So you can see the repulsion because same charges are flowing in both the straws. I rubbed both the straws with a piece of paper. So same charges are flowing. They get repel each other, like charges repel each other. Only unlike charges attract each other. So what you can say, electrostatic force of attraction. The attraction, the force exists between a charged body, the force exerted by a charged body on another uncharged body, or a charged body is called electrostatic force of attraction. Here also like charges get repel each other and unlike charges attracted each other. As you know students, wind blows because of the change in the air pressure. Is there any relationship between pressure and force? Yes, we can define pressure as force per unit area. We can write pressure as pressure is equal to force divided by area. Force per unit area is called pressure. So what does this equation shows? Pressure is equal to force divided by area. It means pressure is directly proportional to the force. Pressure is directly proportional to the force. What does it mean? It means as the force increases, pressure also increases. As the force decreases, pressure also decreases. There is direct relationship between force and pressure. As the force increases, pressure also increases, and as the force decreases, pressure also decreases. So there is direct relationship between force and pressure. What about area? So you can see here area is written in the denominator. What does it mean? There is inverse relationship between area and pressure. Inverse relationship. It means as the area increases, pressure decreases. As the area decreases, pressure increases. So there is inverse relationship between area and pressure. As the area increases, pressure also increases, and as the area decreases, pressure also decreases. For the same reason, usually the bags which we are using to carry books, the strap of the bags are usually wider. Wider straps are used for the bags to carry the books. Bags which is used to carry books or heavier things. So why these wider straps are used? These wider straps have more area. Their area is larger, so that they exert less pressure. They can exert less pressure on the shoulder. So easily we can carry the books. The straps of the bags are wider to reduce the pressure. And also you might have seen the knife which we are using to cut the vegetables or the fruits. The knives or the cutting tools, usually they have sharp edges. You can see sharp edge in the cutting tools or in the knife. Why? Because sharp edge, in the sense area is less, so that exert more pressure. To exert more studied solid exerts pressure. In the same way, liquid also exerts pressure. So, pressure exerted by the liquid at the bottom of the container, it mainly depends on the column of the water which we are taking in the container. So, to understand this, take a water bottle and cut it like this and fix a rubber sheet at the bottom of this water bottle, or invert this water bottle and fix a rubber sheet, or you can fix a balloon at the bottom, at the opening of this water bottle. Now add water, add some water to this water bottle. Just add some water. So you can see this rubber sheet, it gets bulged, it bulges out. If you add more water to the bottle, now add more water. As you add more water here, it gets bulged more expansion you can see. So as the column of water increases in the bottle, pressure exerted also increases. Water exerts pressure at the bottom of the container. As the column, as you pour more water, it gets expanded more. Expansion. You can see more expansion. So it gets expanded more as the water column increases. So you can say here liquid exerts pressure at the bottom of the container, and the pressure depends on the water column. Pressure depends on the column of water. As I said, liquid exerts pressure at the bottom of the container. In the same way, liquid exerts pressure at the wall of the container. On the wall of the container, liquid exerts pressure. Instead of tying this rubber sheet or rubber balloon at the bottom, you can fix a tube at the side of this bottle, and you can fix a balloon or rubber sheet over there. So when you pour the water, at that time also you can see the expansion of the rubber balloon on the side of the wall, which shows that liquid exerts pressure at the wall of the container. And at the same height or at the same depth, liquid exerts equal pressure. To show that, take one more water bottle and cut it in this way. And at the same height, take an equal height. I have taken this height. Make 3 holes. Make 3 holes at the same height. I have taken this much height and I have made 3 holes. Now, add some water to this bottle. Add some water to the bottle. So, you can see here, when you add some water to the bottle, from these holes, water comes out. So, the distance through which this water comes out, it is equal. In the sense, at the same depth, liquid exerts equal pressure on both the holes. Water comes out and this water falls on the same distance between these 2 holes. The water comes out, it travels at the same distance, which shows that liquid exerts equal pressure at the same depth, at the same height or at the same depth. The pressure exerted by the liquid is always equal. So, liquid exerts pressure at bottom of the container, walls of the container, and at equal depths it exerts equal pressure. You know that there is air all around us. This envelope of air we call as atmosphere, and the pressure exerted by this atmosphere is called as atmospheric pressure. So you already studied what is pressure. Pressure is force per unit area. So atmospheric pressure we can define as if you consider a unit area, and if a long then the pressure experienced or pressure exerted by on our head is about 2250 Newton. Even though this much big pressure is exerted, this much big force is exerted on our head, but still, why we are not crushed? Because at the same time, the inside our body is also exerted pressure. Pressure is exerted from the inside our body. From inside our body, there is pressure. This pressure is equal and opposite to this atmospheric pressure. So they get balanced. Because of this, we are not crushed even though this much of pressure is exerted on our body or on our head. We have pressure inside our body, so which is equal and opposite to this atmospheric pressure, so that we can live on the surface of